So we're going to be doing a brief lesson about lines and equations of lines. And to start us off, we're going to be looking at slope equations. Now, you may remember that slope of a line, which we represent with the letter m, is equal to the rise over the run. Now, if you think about the rise, that means going up or down. So that is a difference in the y value. So that's why we subtract y values. Now, if I just have in an equation y minus y, that's just 0. So to tell the different y values apart, I put little subscripts. So I have my first y value, my second y value, and I subtract them. Same with the run, and that means a horizontal movement, either left or right, and that is a difference in the x values. So that's going to be x2 minus x1. And so this is the slope formula. So if I have 2 points, I can find the slope based off of this equation. So let's say I have 1 comma 5 and 6 comma 7, sure. The slope m is going to be y2, so the second y value, which is 7, minus the first y value, which is 5, over the second x value, which is 6, minus the first y value, which is 5. So 7 minus 5 is 2, and 6 minus 1 is 5. We like to leave these as fractions. I could change this to a decimal if I really wanted to, but for our purposes, and especially for this class, uh, the equations are going to be a lot easier to work with fractions. And if I have to graph, again, this is just rise over run. So this means I move up 2 spaces and to the right 2 spaces. Now, in terms of equation of a line, there are many different types, but there are 2 main ones that we're going to focus on. The first type is the one that you might think of immediately. It's slope-intercept form. And so this is y is equal to mx plus b. We have our good friend m, which is the slope, and we have the b value, which represents the intercept. Now, we're going to have an x and a y, and this is because if you have any point on a graph, x comma y, you can think of any x value in the domain, and it gives you a y value. And so that's why we leave x is x, y is y. Those are the variables. Next, we have point slope form. This is helpful for a bunch of different reasons. So if I have y minus y1 is equal to m times x minus x1. So again, we have this m value as the slope. Y and x are the variables, just as they were in slope-intercept form, but we have this x sub 1, y sub 1. That's because this is an actual point. These are constants. They're not variables. So let's say, for example, I give you an equation, and the slope is 3, and the point is 2 comma 1. Y minus y1, this is the y value of the point, so it's 1. The slope is 3, and the x value, so I have x minus the x value, which is the x value of the point, which is 2. This is point slope form for the equation of a line with slope 3 that goes through point 2 comma 1. Hopefully you can see that you can actually change this into slope-intercept form just with a little bit of algebra. Horizontal and vertical lines sometimes confuse a lot of people. If I have an equation such as this, y equals 5, what type of line is this? Well, there is no slope. This is the same thing as y is equal to 0x plus 5. We can see that this slope is a 0. So it's just a constant line going across. In terms of graphing, though, if I have a couple of x values here, this first point, the y value is 5. Second point, the y value is 5. And for every x value in my domain, the y value is 5. So I get a nice horizontal line going across. Same with x. So if I have x is equal to -2, for every y value in the range, x is -2. So there's -2. So if my y value is this point, x is -2. If y is here, -2. If y is down here, x is -2. And so we can see, again, that gives us a vertical line. So it's important to know that whenever you have a y equals a constant, it's a horizontal line. And whenever you have x equals a constant, you have a vertical line. Now, as soon as I throw in a variable here, so if I have y is equal to 5x, this automatically, that's no longer a horizontal line. That's now the slope. So just bear in mind, a constant means there's no variable attached to it. All right, and so here we have some example problems that we can look at and go through. I'm going to take these apart one by one and go through them. So first off, we want to write all these in slope-intercept form, which is y equals mx plus b. So I have a slope and a point, and a slope and a point. For both of these, I'm going to use point-slope form and show you how easy it is to manipulate. So for point-slope form, again, we have y minus y1 is equal to m parentheses x minus x1. So I'm going to have y minus a -5, which is plus 5, is equal to -7/2 times x minus 2. I'm going to keep this y plus 5 over here, and I'm going to distribute the -7/2. So I get -7/2 x, and then I distribute this, so that's from multiplying the -7/2 and the x, and this is from multiplying the -7/2 and the -2. When I multiply, the 2's cancel out because I'm multiplying the fraction by the value in the denominator. So I end up with a positive 7. And if I subtract the 5 from both sides, I get y is equal to -7/2 x plus 2. 7 minus 5. Done. Over here, same deal. I'm going to have y minus the y value, which is 0, is equal to m times x minus a -5. So y minus 0 is just y. And here's a nice part. So minus -5 is plus 5. When we multiply that by 3, a lot of people will think, oh, I have to get out the calculator, I have to put this into decimal form. Don't do that. Just keep it simple. Just multiply the fractions. When you multiply fractions, remember, you multiply numerators by numerators, denominators by denominators. So 5 times 1 is 5. And 3 times the denominator here is 1 is 3. That's it. You can leave it as a fraction. And yes, leave it as an improper fraction. You should not be using mixed fractions anymore. By mixed fractions, I mean this, 1 2/3. That's not going to help us out at all. We want to leave fractions as improper fractions. Okay, now for these points, unfortunately, we don't have the slope, so what are we going to have to do? Well, we'll have to find it. Now remember, slope is change in y over the change in x. So we get the difference of the y values, 3 minus 3, over 0 minus 1. So this gives us 0 over -1, which hopefully you can recognize is 0. So again, I can use point-slope form. So if I have y minus y1 equals m times x minus x1. Now sometimes people ask, well, which point do we use? It doesn't matter. We can use either point, and it's going to give us the same equation. So I'm going to use the first equation here. So I'm going to do y minus 3 is equal to m, which is 0, times x minus 1. Now, anything times 0 is 0, so this right side of the equation just becomes 0. If I add 3, I get y is equal to 3. Hopefully we can see that this is a horizontal line. which makes sense because here, both of our y values are the same. No matter the changing x value, we have a constant y value. It's just a nice horizontal line going across. Over here, same deal, we need to find the slope. So I like positive values. So I see that 5 is bigger than 2. So I can do 5 minus 2. It doesn't matter which order you subtract, as long as we keep it consistent with the points. So I do 5 minus 2. Now I have to do 4 minus 2 to keep it consistent. And this gives me a nice slope of 3 over 2. So if I use point slope form this time, we're going to have y minus, again, either point, doesn't matter. I'll do the first one. So y minus 5 is equal to 3 halves times x minus 4. So I get y minus 5 is equal to, if I distribute this in, 3 halves x. Over here, I'm going to have 3 over 2 times negative 4. You can think of it as negative 12 over 2, or realize that the 2 and the 4, they reduce. Either way, I get negative 6. And if I'm going to add 5 to both sides, I get y is equal to 3 halves x minus 6 plus 5, which is minus 1. And that's my point. That's my equation in slope-intercept form. Okay, now these are a little bit tricky, and I think I have 2 more. Yep. So these are 2 equations that are parallel and 2 equations that are perpendicular. So again, I'm going to use point-slope form, but I need to find the slope. The important thing to know is I want to find a line that's parallel to this. Parallel lines have equal slopes. So hopefully we can see from this equation in slope-intercept form that m is equal to negative 8. So for my new equation, the slope is also going to be negative 8 because parallel lines have the same slope. So I already have my point. So y minus a negative 5 is equal to negative 8 times x minus a negative 3. I can distribute this on the right side, so I get negative 8x minus 24. And if I subtract 5 from both sides, I get y is equal to negative 8x minus 29. Done. Over here, again, this is the slope for this line. And if I'm looking for the equation of a line that's parallel, m is going to be the same value of negative 3/4. So I do, again, y minus 1 is equal to negative 3/4 times x minus a negative 1, which is plus 1. So do y minus 1 is equal to negative 3/4 x. Here, negative 3/4 times 1 is negative 3/4. Now I'm going to add 1 to both sides, but don't forget, if I add 1, I have to add this with a fraction. So I need a common denominator. So if I add 4 over 4, that's the same as 1. So I get y is equal to negative 3/4 x. Negative 3/4 plus 1, or plus 4/4, is just 1/4. Again, we like to keep that as a fraction. Now for perpendicular slopes are opposite reciprocal. Opposite means positive, negative. So for example, the opposite of 5 is negative 5. The reciprocal means you flip the numerator and denominator. So here, it's an ugly m. Here, we can see that the slope is negative 3/4. So what's the slope for the perpendicular line? 4/3. So if I look at my equation, y minus 1 is equal to 4/3 x minus a negative 1, so x plus 1. So I get y minus 1 is equal to 4/3 x plus 4/3. Here I'm going to again add 1, but because I'm adding 1, I need a common denominator. So that's going to be 3, and 1 is 3 over 3. So I get y is equal to 4/3 x plus 7/3. And then finally here, I can see that this slope is 3/7. So the opposite reciprocal, because this is positive, the opposite would be negative, and the reciprocal would be 7/3. So I get y minus 4 is equal to negative 7/3 x minus a negative 3, which would be a positive 3. So I get y minus 4 is equal to negative 7/3. Here, negative times a positive is going to be a negative. Oh, forgot my x. It's going to be a negative. And then the 3's and the denominators cancel out. So I get this minus 7. If I add the 4 to both sides, I'm going to get y is equal to negative 7/3 x plus 4 will give me a negative 3. And so that's it. That's all we're doing with equations of lines. So we want to make sure that we're aware of what to do with perpendicular and parallel lines, what to do and how to find the equation when we're given 2 points, when we're given a slope and a point. Be familiar with horizontal and vertical lines, and know the two equations, the two formulas for the slopes. For the equations of lines with the given slopes. It is important to know that for all the problems I just did, you can do the slope-intercept form. I will not be teaching that way, though. I will be using point-slope form because it's the most straightforward. If you use slope-intercept form, you have to find a value, go back to the beginning, plug it back in, and it's kind of tedious. It doesn't make sense to do. So I don't do it that way. If you want to, that's fine. And if you need help with it, I can help you. But I'm going to be teaching using point-slope form. So try the best with your homework.